Okay, so this is section 10.1 from your Math Links 8 textbook on modeling one-step equations in the form of numerical coefficients or fractional coefficients. So the 4 questions we have here in 7 ask us to solve by inspection. Now the expectation is you can read it and ask yourself a question. So if I read what this question is actually asking me, it would be the variable of j could be what number? That's what the j kind of means. Multiplied by 8, but multiplied by negative 8, that's what the coefficient of negative 8 is. So what number multiplied by negative 8? And the equal sign is the word is. 64 question mark. So this entire equation can be reinterpreted as this particular question. What number multiplied by negative 8 is 64? So we know that 8 times 8 is 64, so we know that our answer is going to be 8 for sure. But the question we're kind of betwixt and between, is it going to be a positive 8 or a negative 8? And it has to be a negative 8 because a negative 8 multiplied by a negative 8, which is what the j is doing, is a positive. So negative times a negative is a positive. So we know the value of that is going to be a negative 8. In the second question, what number, that's our variable n, multiplied by 5 is negative 25 question mark. That's our inspection question. And the answer is n is equal to, this time it's going to be a negative 5 because a positive 5 multiplied by a negative 5 is a negative 25. Next question, I'm going to read it backwards. So what number, that's our k, divided by 3, which is what this means right here. What number divided by 3 is negative 6? That's what that particular equation says. What number divided by 3 is negative 6? So what number divided by 3 is 6? Forget about the negative and positives, Taylor. What number divided by 3 is 6? 18. Now, is that going to be a positive 18 or a negative 18? It has to be negative because a positive divided by a negative or a negative divided by a positive is a negative. And our last question, our x variable would be what number divided by negative 11 is negative 4? And the answer for that is, it is a positive 44. So if I substitute that x for positive 44, are those two sides the same? Yes, they are. So for question 8, this time it says use mental math to solve each equation. So I don't have to write down my question, but I do have to ask that same question. So 3 times what number is negative 12? R has to be negative 4, solving by inspection. Negative 4 times what number is negative 16? It's a positive 4, so P equals positive 4, or just 4. What number divided by 2 is negative 30? It's T has to be negative 60. Negative 60 divided in half is negative 30. And final, what number divided by negative 4 is 5? D equals negative 20, because negative divided by negative is a positive. So question number 9 is actually a grade 7 question because we're dealing with modeling of algebraic equations. So it says 2k is equal to negative 8, model to solve. So if each of these represents a variable, we're going to make this k or x or whatever we want to be, equals negative 8. Then when I draw it, that's what it looks like. 2k's is equal to negative 8. And I don't want to know what 2k's is. If 2k's is equal to negative 8, then each of these k's divided onto its beautiful scale, and divide the other side onto each side. This scale actually tells your answer. A k has a weight of 4. In our B question, same scale, so our equal sign really is showing the balance. Negative 3 is equal to, how do I read this particular expression, t over 4? Deacon, how do I read t over 4? What divided by 4 is one way? What's another way to read it? Taylor? A quarter of t. Now that's the better way to read it, because if I take a quarter of t, if this whole thing is t, then a quarter of t, or t divided into 4 parts, is really that picture right there, right? But I don't want to know what a quarter of t is. I want to know what all of t is. So what I'm going to do to solve it is I'm going to take this side, excuse me, and I'm going to multiply it by 4. I'm going to quadruple this side. But if I'm going to keep things balanced, if I quadrupled one side, I have to quadruple the other side. That's doubling it, that's tripling it, that's quadrupling it. And when I think about what these 4 quarters would equal, from a balancing standpoint, it would equal a full t. And over here, I'm not going to draw it out again, but I'm going to have 12 negatives. So what this says, if I interpret the scale, is negative 12 is equal to t, or if I flip-flop it, t is equal to negative 12. Okay, question 11 is so easy because it says, what number would you divide both sides by of the equation to solve it? Now remember, our goal is to get the variable by itself. That's called isolating the variable. So because this says negative 3 multiplied by x, we want to use the opposite operation to both sides. So here, we're actually going to divide both sides by negative 3. So if I did that, divide by negative 3 and divide by negative 3, x would equal a negative 3. Over here, I'm going to divide both sides by negative 4. So when I do that, divide by negative 4 and divide by negative 4, I'd get g equals a positive 8. Over here, because I'm multiplying t by negative 9, I'm going to divide both sides by negative 9 to isolate t. And that would equal a positive 8. And finally over here, because I'm multiplying p by 4, I'm going to divide both sides by 4. And p would equal negative 2. Question number 13 says use opposite operation to solve. So what we're going to do here is I'm going to interpret what it says. This is multiplying s by 4. So the opposite operation is dividing. So I'm going to divide both sides by 4 to keep it equal. And s will equal negative 3. Over here, divide both sides by negative 12, which is your coefficient. And by doing so, you isolate your variable. How many 12s in 156? There are 13. Is that positive or negative? That's right. It is a positive because a negative divided by a negative is a positive. Over here, I'm going to divide both sides by negative 4 to get rid of multiply by negative 4. And j equals 26 negative. And over here, I'm going to divide both sides by negative 27, the coefficient. Isolate for t, and that equals positive 4. Question 15 doesn't say solve it, it just says what do you do to both sides to isolate the variable? Sorry, I just paused there, but we have to figure out what do I multiply both sides by. So the first thing I need to be able to do is read that as g divided by negative 6. And if I read that as g divided by negative 6, to get rid of that divided by negative 6, I'm going to multiply by negative 6. So I'm going to multiply this side by negative 6 over 1, or just negative 6. I'm just going to write it like this, though. Multiplying this side by negative 6, and multiplying this side by negative 6, I would isolate, and I would get negative 78 for my answer. I don't have to solve it, but I will anyway. What do you do to both sides here? I'm going to multiply both sides by 3, and m will equal negative 75. Over here, I'm going to multiply both sides by negative 21, and n will equal positive 126. And over here, I'm going to multiply both sides by 17, and z would equal, notice how I made my z with a little line through it. If you don't use a line through your z, it looks an awful lot like a what? A 2. So put a line through the z to make it clear that it is a z. 102, I think. 106? No, it's 102. So question 17 asks us to solve each. So again, we're going to use opposite operation to solve it. T divided by 3 multiplied by 3 will leave us just with t. Since I multiplied both sides by 3, I get t equals negative 36. T divided by negative 10 multiplied by negative 10 is h. Multiply both sides by negative 10, negative 120. S divided by negative 7 multiplied by negative 7 equals s. And over here we get 105 negatives. And multiply both sides by negative 3. X equals negative 48. So for question 19, the instructions say show whether x equals -2 is the solution for each of these equations. If it is, say yes. If it's not, say no. So does x equal -2 for both? Now there's two ways you can do this. The easiest way would be to solve it and see if x is -2, right? An easier way is actually to substitute the x. So it says -8x, which means -8 times -2. What is the product of -8 and -2? It is +16. So yes, the solution to A, x equals -2, is correct. Over here, substitute my x for -2. Oh, -2, not -20. Does -20 equal -20? Yes. Therefore, x is -2. Over here, substitute -2 for x. Is -5 times -2 10? Yes. -2 is the solution. And if I substitute -2 over here, -36 does not equal a +36. So therefore, for D, -2 is not the solution for x and D, but it is for the other three. Now the last three questions we have are story problems. So we're going to solve it algebraically. In all of these story problems, we're going to solve it the exact same way. So what I want you to be aware of, Colby, is that the strategies and the expectations for each of these questions is going to be the same for all of your test questions. So it says for the month of January, the average afternoon temperature in Calgary is a quarter of the average morning temperature. The average afternoon temperature is -4 degrees Celsius. What is the average morning temperature? So the first thing we're always going to do is define our variable. I'm going to say what x in my equation is going to represent. And 97% of the time, if you go back into your actual last question where the question mark is, that will always be your variable. So what is x going to represent here? It's going to represent the average morning temperature, AM being morning. Okay? So your x is going to be your average morning temperature. Oh, sorry, not x. For reading my questions, what should I use instead of x? M. If m represents the average morning temperature, what equation models the solution? So, what is the average afternoon temperature? I'll do PM here. If x is going to be the average morning temperature, what algebraic expression will represent the afternoon temperature if it's a quarter of the morning temperature? Tori, what will that be? Thank heavens I wasn't recording that. But if m equals the average morning temperature, then m over 4 is going to represent a quarter of the average morning temperature. That's going to be our afternoon temperature. Now, since we already know that -4 degrees is actually the afternoon temperature, then our next step is to create an equation. So this expression, which is the average afternoon temperature, is m over 4, but it's also -4 degrees. So those two things are the same. That algebraic expression of a quarter of the morning temperature and -4 degrees are the same thing. So I can make an equation because they're the exact same thing. Now to isolate, we're going to multiply both sides by 4. Or we're going to solve it that m equals -16. Now I got to go back into where I define my variable. So we already know that this is -4 degrees Celsius. We already know that. What's the average morning temperature? It's -16 degrees Celsius then. We've now solved for it because m is the average morning temperature and it's -16. So our final sentence would be, therefore, the average AM temp is -16 degrees Celsius. So to recap, step 1 is always define your variable or variables, depending if you make two different expressions. Step 2 is write an equation. Step 3 is solve the equation using opposite operation. And step 4 is to write a sentence saying you know what your answer says. So for the next question, we're dealing with Nakasuk. Snowmobile can travel 13 kilometers on 1 liter of gas. He is going to visit his aunt in a community 312 kilometers away. Nakasuk wants to know how many liters of gas he needs to travel to his aunt's community. Write the equation in the form of AX equals B. So the first thing we're going to do is define our variable x. X is going to be exactly what I told you before. How many liters of gas he needs. How many liters of gas? How many liters of gas he needs. So if I think about 1 liter of gas or 2 liters of gas, since 1 liter of gas can go 13 kilometers, then 13 multiplied by x will equal total distance. And you need to think about this for just a second. If each one of these x's, the liter of gas, if it's 1 liter of gas, that x is 1. And since each liter of gas can go 13 kilometers, I'm going to multiply the number of liters of gas, x, by 13, and that will tell me the total distance. Because 1 liter will be 13 kilometers, 2 liters of gas will be 26, 10 liters of gas will be 130, and so on and so forth. So since I want to go 312 kilometers, then the total distance I have in gas as an expression is this. The total distance, is it 132? Oh, 312, sorry. Now I've created my equation. How much gas, how many liters of gas, each one of those goes 13, has to be equal to the 312 kilometers in total I need to travel. So, solve it by dividing both sides by 13. And that will tell me the number of liters of gas I need. 312 divided by, each liter is 13 kilometers. Therefore, I need 24 liters of gas, right? So therefore, to travel 312 kilometers, he needs 24 liters of gas. Just to be clear, step 1, define your variable. Create another algebraic expression based on that to see if you can use it. Create an equation. Solve the equation using opposite operation. And write a sentence to make sure you understand what you solved. And your last question talks about the pygmy owl versus the great owl. The height of the great owl is 5 times the height of the pygmy owl. A great owl can reach up to 85 centimeters. What's the question? Oh, yeah. What is the height of the pygmy owl? So X is going to represent the pygmy owl's, P-Y-G, pygmy owl's height. Okay. The great owl, if the pygmy owl is X, and a great owl is 5 times as big as a pygmy owl, what algebraic expression will represent the great owl's height? Not all at once now, because it gets chaotic if you all yell the answers because you're so excited. If a great owl is 5 times as big as a pygmy owl, and the pygmy owl is X, what expression represents the great owl's height? That's right, 5X. I'll just pretend somebody said it. Thank you. How tall, which one do we know? Do we know the great owl or the pygmy owl? The great owl is how tall? 85 centimeters. So this expression and this height are the same thing, which means the great owl's height as an algebraic expression and the actual height of 85 centimeters is the equation we're going to use. We're going to divide both sides by 5, and we're going to figure out that the pygmy owl's height is 17 centimeters tall. So therefore, the pygmy owl's height is 17 centimeters.